Sophie. You're watching the first ever video of the science of it. Have you ever wondered how we managed to send rockets into space?
And liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Newton discovered the law of gravity, which allows us to explain why objects like this apple fall towards the ground.
Since the force of gravity is directly proportional to the mass of the objects, more massive objects will attract each other with a bigger force. So, as the mass of either object increases, it means the force of gravitational attraction between them also increases.
As the force of gravity is inversely proportional to the square of the distances between the two objects, this means when you move objects further away, the force of gravitational attraction between them also decreases. But when we're launching things into space, we generally don't want them to fall straight back down again. So how do we get around this? Well, Newton's first law tells us that an object will remain at rest or in constant motion unless an unbalanced force acts on it. So this means that if we throw this apple in a straight line, then it will keep going in a straight line until gravity pulls it back down to Earth.
But if you threw the apple fast enough, then it would keep falling towards the Earth, but it would never hit the ground, since the curvature of the Earth would be the same as the flight path of the apple.
And that's how satellites stay orbiting the Earth. But Newton also had some other laws that can help us explain how rockets can get into space.
To get a rocket into low Earth orbit, it needs to be travelling over 17,000 miles per hour. Newton's second law tells us that we can accelerate the rocket to reach these speeds by applying a force. So a larger force, or a longer time applying it, means a larger acceleration. But if the force is too big, then the rocket could be destroyed. As the rocket burns fuel, its mass decreases, so it takes less force to accelerate the rocket to higher speeds.
And using the same principles as rocket scientists use to get rockets into space, you can actually make your own rocket at home, although you might not get into space.
You should definitely try this one at home. All you'll need is tape, a straw, a balloon, and some string. Blow up the balloon and stick the straw to the top using the tape. Then thread this through the string and tie it tightly between two chairs. The balloon in this experiment is going to act as our rocket engine. When it's tied shut, it's in a state of equilibrium. But when we let go of the balloon, the air trapped inside pushes out of the open end, causing the balloon to move forwards. This is a great way of showing us Newton's third law. We could say that the force of air escaping is the action, and the opposite reaction is the balloon moving forwards. Why not see how far you can get your balloon to go? You'll just need a longer bit of string. The distance that the balloon will travel in a straight line is related to the amount of air trapped inside the balloon when you let go of it. In a similar way, the distance a rocket will travel is related to the amount of fuel inside the rocket engine.
T-minus 5, 4, 3, 2, 1.
Endeavour's roll maneuver is complete. It is now in a heads-down position on track for its flight to the International Space Station.
So now you know how Newton's laws help us to get rockets into space. Hope you enjoyed, and I'll see you next time.